Alrighty, we are talking about 7.3 and specifically predicting the products of single replacement reactions. So this is the first section under 7.3. So here we go. These are actually in your notes under 7.2 as well, or they should be. So you don't necessarily need to rewrite them if you already have it, but this is what should go in 7.3 for single replacement reactions. So the first thing to keep in mind when you're predicting single replacement reactions is that the free element is only going to replace the type of ion it likes to be. For example, if you have the following single replacement reaction, chlorine would like to be a negative ion. So it's not going to switch with sodium, which is positive. It's going to switch with the iodine, which is the negative part of that compound. And we're going to get sodium chloride, and then iodine will be the free element. Secondly, the element must be more reactive than what it is replacing for the reaction to occur. So you're going to check what's known as the activity series chart. For example, potassium plus sodium iodide. Potassium would like to be positive, so it's going to switch with sodium. Since potassium is higher up on the activity series, that means it's reactive enough to kick out sodium. And you would get potassium iodide plus sodium. If, however, you were to take silver and try to react it, it would like to be positive with magnesium, you'll notice that silver is lower on the activity series. So it is not reactive enough to kick out magnesium, which means this reaction is not going to happen. Since it's not going to happen, we don't predict products because there won't be any. We just write no reaction. So that's it for single replacements. Now we're going to skip ahead to double replacements. To predict the products of double replacement reactions, first you should know that they're always going to occur in aqueous solutions where each reactant is first dissolved in water. You're either going to form water or a precipitate, which is a solid, insoluble compound. So we're going to go ahead and define that right here. So a precipitate, a PPT, is a solid, insoluble, meaning it doesn't dissolve, ionic compound. Okay, since it's solid and insoluble, it's like sand. You can dump it in water and stir it up, but it's not going to dissolve. So remember, both of those solutions were aqueous, meaning whatever you started with did dissolve. So it's going to look like all of a sudden you have a solid substance kind of floating around where you didn't have one before. That's called a precipitate, and remember, that's indicated by a down arrow next to it. So you either have to find water, and if water is not a product, you're going to check the solubility chart, which is on the back of your activity series, to see which product is your precipitate. And that's going to be the one that has either a P or an I, which means partially soluble or insoluble. Okay, so here's some examples. I want you to practice these, see what you get as products, and then we'll check our answers together.